Hello, welcome back to Star Learners. In this week's Star Learners, we're once again discussing the question of, do aliens exist? And this week I'm going to discuss two places out in space that are habitable and where life could exist. Okay, first up, we've got Europa. Europa is one of Jupiter's many moons. Jupiter, as of 2020, has 79 confirmed moons. So Europa is a really unique kind of moon. It's an icy, ocean-filled moon, and it has twice as much water as Earth. Europa's ocean is a subglacial saltwater ocean. It's 62 miles deep and covered by a layer of ice. There is no land to speak of at the surface. It is simply an ice-covered surface. There are also huge plumes of water vapor that blast through the surface. This water vapor can blast up to 124 miles high, and that is the equivalent to 20 Mount Everests on top of each other. So there's clearly something going on in that saltwater ocean beneath the ice that causes water vapor to blast through the layer of ice that is 6 miles deep. Now, this is important because if water is able to escape the ocean, then it's likely that key elements for life, like carbon and oxygen, are able to enter it. In Earth's oceans, carbon and oxygen are key elements for life. And this could be the same on Europa. But one other necessary thing for life on Earth is heat. And if Europa has a 6 mile deep layer of ice, it doesn't appear like it would have a heat source. And of course, it's a moon, so it doesn't have a host star that it orbits and where it could receive heat from, like Earth does. The oceans on Europa are liquid, so there must be something going on that keeps it liquid. And surprisingly, Europa's heat source is Jupiter. Europa is heated due to the way that it's pulled in orbit around Jupiter. Just like the Earth's tides are caused by the gravitational pull of the moon, Europa also has tides, and they're caused by the gravitational pull of Jupiter. So these tides prevent the liquid water beneath the ice from freezing solid. It's called tidal heating, caused by tidal pressures and tidal energy. This tidal energy gently heats Europa from its core. Additionally to this, Europa is the only other celestial body in our solar system that has plate tectonics. So you know on Earth we have tectonic plates and that they move. When they push together or move apart, they can cause volcanoes, earthquakes, and tsunamis on Earth. Now, what is less known about tectonic plates is that they can cause hydrothermal vents at the bottom of the ocean. So when tectonic plates move either together or apart, they can cause these hydrothermal vents at the bottom of the ocean floor, and the heat from the hydrothermal vents causes the cold seawater around it to warm up. So the cold seawater is heated by the hot magma in the Earth's mantle, which is the layer between the core and the crust. So hydrothermal vents are kind of like hot springs or geysers on the ocean floor that heat the surrounding seawater. And on Europa, exactly the same thing happens because of the tectonic plates. There are hydrothermal vents at the bottom of the ocean floor, which then heats the surrounding seawater. So that is another heat source for Europa. And that would also explain the plumes of water vapor that blast through Europa's icy surface. Now, when it comes to life, we know that microbes can live in the warm water around the hydrothermal vents on Earth. And the hot water around these vents is supposedly where life first originated on Earth. More recently, scientists discovered something around one of these hydrothermal vents. They discovered hundreds of shrimp all piled on top of one another, crawling around this vent, thriving in these conditions. So these deep, hot ocean conditions are fantastic for some forms of life to exist and potentially evolve into more intelligent life forms, like here on Earth. An animal like this could exist at the hydrothermal vents on Europa right now. Life on Earth originated in the sea, so it's really not too far of a stretch to say that this could happen on Europa, or has already happened. Plus, if this isn't already enough evidence to support potential life on Europa, it's so unique that it's the only other celestial body in our solar system that has plate tectonics. So it really wouldn't be surprising if it was the only other celestial body in our solar system to host life. So, whilst the surface of Europa is seemingly uninhabitable due to the thick layer of ice, life really could exist right now in the ocean beneath it. possibly even loads of shrimp all piled on top of each other and crawling around one of Europa's hydrothermal vents. Okay, option number 2, Proxima B. Proxima B is an exoplanet, which means it's a planet that orbits around a star outside of our solar system. Proxima B orbits around Proxima Centauri, which is our sun's closest neighbour. It's still 4 light years away, but it is our second closest star. Now, Proxima B might host life because it is in the habitable zone of its star, Proxima Centauri. Now, remember, the habitable zone is that Goldilocks zone, so it's not too hot and it's not too cold, and therefore liquid water could exist. For example, Earth, we are in the habitable zone from our sun. Now, planets in a habitable zone are more likely to have the possibility of life existing because of the option of liquid water existing, as we saw with Europa. And if we go back to how Earth originated, or life on Earth originated, then water has a very big part to play. Now, the problem with Proxima B is that it's tidally locked. And what this means is that it's synced in rotation with its star. This means that one side of the planet will always be facing the sun and always be roasting hot, and the other side of the planet will be freezing cold and dark. However, solar wind slamming the hot side of the planet would blow heat from the hot side to the cold side. So that would be a solid means of energy transport. Potentially somewhere in between the hot side and the cold side of the planet, life could flourish. Additionally, this in-between temperature from the hot side and the cold side would give water more of a chance of staying on the planet. And we know that life has more of a chance of existing if there's water. So life may already have evolved and developed on Proxima B that we just don't know about. Remember, it's 4 light years away. That means if you were riding a light beam and moving at the speed of light, it would still take you 4 years to get there. So it may be the case that intelligent beings have evolved and are thriving in that in-between part of the planet where it's not too hot or cold. Or they've developed and become so intelligent that they're living in the shadows, in the dark side of the planet, hiding from us. So clearly the link here between potential life existing on a planet is liquid water. So far, Earth is the only planet that has confirmed life. But I think this has proved that realistically there are lots of potential worlds out there where life could exist that we just don't know about yet. Out of these 2 planets, or potential places that life could exist, Europa is our closest, as it's in our solar system. What we really need to do is get out to Europa and drill through that 6-mile deep layer of ice. Once we're through the ice, we can measure the water and find out what is going on in there. Maybe even catch some shrimp while they're there. So maybe one day we'll make it out there. But for now, let's just imagine that our closest alien friends are lots of little shrimp living in the ocean on Europa. Okay, once again, thank you for watching and subscribe to this channel for more quick videos.